All right, hello and welcome to your 4.1 video notes. This is on graphing linear equations. So, we are going to graph a linear equation using ordered pairs. We did this a little bit yesterday as well. So we have our table and our graph and our equation. So we're going to take our equation, plug in our x values, get out our y values to create points to graph on the line. Yesterday we just figured out how to find a y value if we were given an x value. So today what we want to do is figure out if an ordered pair is a solution to a linear equation. So we're going to do the same thing that we did yesterday, except for now we have an x and a y value. Sorry if it gets a little blurry here, it'll go in and out. I can't figure out how to make it just be. And we're going to plug those in to our x and our y here in the equation. I'm moving it, see if that helps. So I'm going to plug 0 in for x and 4 in for y. So it's going to be 3 times 0 plus 2 times 4 equals negative 8. Now we're not trying to solve anything. We're not trying to find an x or a y value. We already know what they are. What we're trying to do is see if they solve this equation, if they create a solution. So what we're going to do is just simplify one side of the equation. So 3 times 0 is 0, 2 times 4 is 8, equals negative 8. Continue to simplify. 8 equals negative 8. That is not true. 8 does not equal negative 8, so we're going to say that no, this is not a solution to the equation. Let's try our next point. We have an x and a y value. See if I lock it, sorry, I'm trying something on the thing. Nope, don't do that. So we have an x and a y value here, negative 2 and negative 1. Why is this all blurry now? There, maybe that worked. So we'll plug x and y into our equation. So it'll be 3 times negative 2 plus 2 times negative 1 equals negative 8. And let's see if it works this time. So 3 times negative 2 is negative 6. 2 times negative 1 is negative 2. Continue to simplify. And negative 8 does equal negative 8. That is true. So we do have a solution to our equation. So we'll say yes. This point is a solution to that equation. All right, for the next part, we're going to graph. When we graph, we want to create a table of values and plot those points. Now, I told you already that I'm going to give you the tables, the same kind that we had on yesterday's notes, and actually if you look on the completed notes that are posted online, it will have one of those large tables there as well. I'm going to show you how to make a smaller one. If you prefer the bigger one, that will be present on your homework and it will also be present on the checkpoint. But really all you need is a simple x, y table. For now, I'm going to give you the x values. So I'm going to tell you, and you will be told on the checkpoint, that we're going to use negative 1, 0, and 1 for our x values. And now we just need to figure out what's going to become our y values. So we're going to plug our x values into x in the equation and figure out what comes out. So I can say that y is equal to negative 2 times negative 1 plus 1. Y is going to be 2 plus 1. That's 3. Then y is going to be negative 2 times 0 plus 1, which is going to be 0 plus 1. That's 1. And then lastly, y is going to be negative 2 times 1 plus 1. That's negative 2 plus 1. That's negative 1. So, as I already said, this will all be on one big table just like it was yesterday. So these are our points. So I have the point negative 1, 3, 0, 1, 1, negative 1 to plot on my graph, make a straight line through them. And we talked yesterday about, do we put arrows on? Whenever we just have a plain equation that's not a story problem, yes, arrows go on both ends. And eventually, we will talk about how to choose the best x values for whatever equation that you are given. But I did want to remind you that every equation requires at least 3 points to become a graph, which is why I chose 3 x values. So let's go to the next one. Why don't you, at this point, and I should have said this earlier for up here as well, but why don't you pause the video, try to figure out B on your own, and then come back and see what you guys get. So for B, the x values that I would have chosen for you are negative 2, 0, and 2. And I'll talk about why as I solve it. So for negative 2, y is going to be negative 1/2 times negative 2 plus 2. Now you can kind of see why I chose negative 2. Whatever I choose for x, I'm going to have to multiply it by negative 1/2. Essentially divide it by negative 2. So I want to choose values that are easily divisible by 2, such as negative 2 and positive 2. It makes it easier. So negative 1/2 times negative 2 is just going to be 1. Plus 2 is 3, so this value will be 3. 0 is always a great value to choose because multiplying by 0 is super easy. So this is going to be 0 plus 2. That's just going to give me 2. And then I also chose positive 2. Negative 1/2 times 2 plus 2. That's negative 1 plus 2. That's going to give me 1. So these are our points. So I'm going to plot those. Negative 2, 3, 0, 2, 2, 1. Draw my line through the points with my arrows. Okay, so that's graphing a plane linear equation. Now we're going to talk about horizontal and vertical lines. Horizontal and vertical lines are always going to follow the same type of pattern. Y equals a number is always going to be a horizontal line, which is a line that goes across like this. X equals a number is always going to be a vertical line. Vertical lines go up and down like this. And what these equations are saying is that y is a line passing through the point 0b. Oh, it was up here, sorry. Yes, I can erase it. That's our line. And x is a line passing through 0a, and it's all the points that are on that line. So let's do a couple examples. I have y equals negative 3. This tells me that my graph is going to be all the points where the y value is negative 3. So here is my y value being negative 3. That's where negative 3, here, 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 here. All of these points are where y has a negative 3 value. So that's going to be a horizontal line through all of those points. Pause the video and see if you can do B. X equals 2. So x equals 2 is going to be a line. And it's going to be where all the points where x equals 2. where the x value is 2. So here's the x value of 2. So here and here and here and here and all of these points. Let's draw a line through them. So this is going to be our vertical line, x equals 2. All right, last one. This is saying the wind speed of a tropical storm is this equation, where x is the number of hours after the storm enters the Gulf of Mexico and y is the wind speed in miles per hour. We want to know when the wind or when the storm becomes a hurricane. And it's kind of giving us a clue to that over here. The storm becomes a hurricane when the winds reach at least 74 miles per hour. So what we're going to want to do is graph this and take a look at what we see when the winds reach 74 miles an hour. So I have the equation y equals negative 2 or 2x plus 66. I'm going to start with my table. So x is the number of hours after the storm enters the Gulf of Mexico. So let's figure out what some values for x could be that are going to make sense here. Well, 0 hours is as low as you can go. You can't have negative time. We talked yesterday about how you want to try to find like the minimum and possibly the maximum and go from there. So the minimum number of hours that the storm could be in the Gulf of Mexico is 0. And let's go from there. So maybe it's there for 1 hour. Maybe it's there for 2 hours. Maybe it's there for 3 hours. I know I just did 4 points, but I'm just kind of making a point here. So let's find our subsequent y values. Y is equal to 2 times 0 plus 66. That's going to be 66. Y is equal to 2 times 1 plus 66. That's going to be 68. Y is equal to 2 times 2 plus 66. That's going to be 70. Y is equal to 2 times 3 plus 66. That's going to equal 72. I think you can kind of see what's going to happen here with when the storm becomes a hurricane, but I want to show you algebraically and graphically how you could solve this. So algebraically, I'm already seeing a pattern here. 66, 68, 70, 72. I'm going up by 2 each time. It looks like I just have to go one more to reach that 72 miles an hour. So I could plug in 4 and see what comes out. Graphically, I'm going to plot these points. So I'm going to go 0, 66. Whoops, that's not 66. That's below 64. 0, 66. 168. 270. 372. And when I draw my line through these points, I have to think about my arrows. I'm not going to have any line or arrow going this way because that would be saying that my time is negative, right? That would be going on my x values over here into the negatives, and that doesn't make sense. So when I draw a line, I'm going to have it continue going that way only, right? Because more time can pass. We don't know how long the storm is going to be in the Gulf of Mexico. It could be several hours. Then, graphically, if I want to find the point where it reaches 74 miles an hour, 74 miles an hour is my y value. That's right here. And all I'm going to do is take that across to my graph, which is right here. So there's the point 74 on my graph. And then take it down to my x axis to find the number of hours, which is 4. So it's going to take 4 hours. After 4 hours, the storm will be 74 miles an hour, and the wind will be 74 miles an hour, and the storm will become a hurricane. All right.